Welcome to the Sleepy Astronomer, where the mysteries of the cosmos gently guide you into rest and wonder. Tonight, we're drifting into one of the most fascinating and mysterious places in the universe, the heart of a black hole. But before we begin, where in the world are you watching from? Are you curled up in bed in Norway, listening from a quiet room in India, or maybe watching the stars from somewhere in the southern hemisphere? Wherever you are, know that you're part of our peaceful little constellation of curious minds. Now take a deep breath, get comfortable, and let's begin our slow descent into the unknown. Somewhere far away in the vastness of space, a star begins to die. Not just any star, but a massive one, many times larger than our own sun. For millions upon millions of years, it has burned with unimaginable energy, holding a delicate balance between gravity pulling inward and nuclear fusion pushing outward. Deep inside its core, atoms of hydrogen have been fusing into helium, and in doing so, releasing the light and warmth that once may have danced across distant planets orbiting its warmth. But now, its fuel is nearly gone. The hydrogen is depleted, and the process begins to change. Heavier elements form as the star tries to keep itself alive, fusing helium into carbon, and then into even heavier elements. Each new stage burns faster, more desperately, like a candle reaching the end of its wick. And then, one day, perhaps quietly, perhaps in a magnificent explosion, the core can no longer support the immense weight of the star above it. Gravity wins. In a moment shorter than a heartbeat, the star collapses inward. Imagine something the size of our sun being squeezed down smaller than a city, smaller than a mountain, smaller than a grain of sand. The matter becomes so tightly compressed that its atoms can no longer resist. Even the space between particles vanishes. The very fabric of reality begins to fold inward, deeper and deeper, until it forms a singularity, a place where density becomes infinite, and the known laws of physics break down. Around this singularity, a boundary forms, a quiet, invisible sphere known as the event horizon. It is not a wall or a surface, but rather a point of no return. Once crossed, nothing, not even light, can escape. This is the moment a black hole is born. No fireworks, no sound, just silence. And yet, from afar, the space around it may begin to glow. As the black hole's intense gravity pulls in gas, dust, and perhaps even entire stars, the matter forms a swirling disk around it, called an accretion disk. This disk spins at incredible speeds, heating up from friction and glowing brightly in X-rays. It is not the black hole itself that shines, but the chaos just outside its grasp. Black holes can be small or unfathomably large. Some are only a few times the mass of our Sun, formed from single stellar deaths. Others, supermassive black holes, lie in the centres of galaxies, including our own Milky Way. These giants are millions or even billions of times more massive than the Sun, and yet they too began, long ago, as something simpler. The story of a black hole's birth is a story of transformation, from life to death, from star to shadow, and yet nothing is truly lost, only changed. The atoms that once made up a star now become part of something far stranger, far more mysterious. As we drift deeper into this cosmic journey, remember, every black hole was once a shining star, burning brightly in the sky, perhaps not so different from our own sun. It lived. It shone. It gave light to its corner of the universe. And then, when its time came, it quietly became one of the most mysterious entities in existence. Let yourself float now, gently, through the darkness left behind. There is more to see. There is more to understand. And the journey has only just begun. As we drift closer to the black hole, we reach the very heart of its mystery. A place so strange and so foreign to our understanding of reality that even the most brilliant minds in science can only speculate about what lies within. This heart is known as the singularity. The word itself carries a sense of gravity, pun intended. In mathematics, a singularity is a point where something goes to infinity. In physics, it is a place where the values that describe the laws of the universe, mass, density, curvature of space, begin to spiral out of control. Here, everything we know unravels. The singularity is not just a place. It is the ultimate breakdown of our understanding. And inside a black hole, this breakdown hides at the very center, cloaked behind the event horizon, forever shielded from our direct view. To imagine the singularity, picture all the mass of a massive star, millions or billions of tons, compressed into a single point. Not just a small point, but a point with no volume. Infinite density, infinite gravity. Time and space themselves twist and fold into this singular region, as if reality is being crushed into an unimaginable knot. The closer you get to it, the more distorted everything becomes. Directions cease to have meaning. Time may stop flowing forward in the usual way. Space might stretch infinitely in one direction while folding in on itself in another. It's important to realize that no one has ever seen a singularity. No telescope, no probe, no spacecraft will ever reach it, because to cross the event horizon is to leave our universe behind. All the information we could gather is lost to us. What happens inside is hidden forever. Even light, the fastest thing in the universe, cannot escape to tell us what it saw. Einstein's general theory of relativity tells us how gravity works, and it predicts that singularities must exist inside black holes. But relativity is only part of the picture. When we look very closely at the tiniest scales of reality, much smaller than atoms, we need quantum physics to make sense of things. And here's where the puzzle begins. Relativity and quantum mechanics are like two musical instruments playing in different keys. They describe different aspects of the universe beautifully on their own, but when brought together at the singularity, their melodies clash. This is why scientists believe that to truly understand the singularity, we need a unified theory. Something that can blend gravity and quantum physics into one harmonious explanation. Some theories suggest that the singularity may not be a point at all, but something fuzzier, something more complex, shaped by quantum forces we don't yet understand. Others propose that the singularity could be replaced by a loop of energy, a region of space-time in which time curves back on itself. And still others imagine that singularities might be portals, gateways to new universes, entirely separate from our own. Yet for now, these are only ideas, elegant, fascinating but unproven. One of the strangest things about the singularity is that it challenges our very idea of cause and effect. In the rest of the universe, one moment leads to the next. Events unfold in sequence, but near the singularity, that chain may break. The normal flow of time could reverse, fragment, or even become meaningless. We don't know if an object crossing the event horizon experiences time at all in the way we understand it. Perhaps it all happens in an instant. Perhaps it stretches forever. There's also the question of what it feels like to fall toward a singularity. Not physically, you wouldn't survive long enough to feel much at all, but from a theoretical perspective. Would you feel time slow to a stop? Would you see the universe stretched behind you, frozen in a final moment of light? Or would it all blink out instantly, leaving only silence? Some physicists speculate that matter doesn't truly disappear into the singularity, that somehow the information it contains, the record of its existence, is stored or transformed, woven into the surface of the event horizon in a way we don't yet understand. This is called the holographic principle, and it opens the door to yet more strange ideas. That perhaps everything we see in the universe is a projection from deeper layers of space and time, encoded at the edges of reality. When we speak of a singularity, we are not just speaking about a place in space. We are speaking about the limits of human understanding, the end of our maps, the moment where science meets mystery, and where the language of mathematics whispers, "Here be dragons." And so, in this deep and endless darkness, we pause, not with fear, but with awe. For the singularity reminds us that the universe still holds secrets far beyond our grasp, and that some of the most important discoveries may lie in the silence between what we know and what we can only dream of. Let us linger here in quiet curiosity before we continue our slow descent. There are more wonders waiting. Imagine floating in the vastness of space, watching the stars drift silently in all directions. Then in the distance, you notice something strange, a patch of sky that seems to be swallowing light. A dark circle, perfectly black, surrounded by a glowing halo of swirling matter. As you drift closer, this darkness grows, but not in the way a shadow grows. It does not simply obscure light, it consumes it entirely. This boundary, this invisible shell surrounding the heart of the black hole, is known as the event horizon. The event horizon is not a surface you can touch or see. It does not shimmer or ripple like water. It has no texture, no thickness, no glow. But its presence is unmistakable. It is the line that separates out here from in there. It is the threshold where the rules change completely. If anything, whether it be a particle, a photon of light, or even time itself, crosses this boundary, it cannot return. Not because it chooses not to, but because it physically cannot. The escape velocity, the speed needed to get away, is greater than the speed of light. And since nothing moves faster than light, nothing escapes. That's why black holes are black. To understand this more clearly, let's go on a slow, dreamy journey toward the event horizon. You're drifting peacefully in your spacecraft. From a distance, the black hole looks almost gentle, silent, still. Around it, The gravitational pull is strong, but not yet dangerous. You still have time to turn around, time to think, time to wonder. But every moment you wait, the pull grows stronger. The closer you come, the more space itself seems to stretch. If you tried to send a message back home, it would become slower and slower, its frequency dropping, its energy fading, until it could no longer be heard. You are approaching the boundary. Now, if someone were watching you from a distance, a friend, far away in a safe orbit, they would see something strange. As you near the event horizon, your movements would appear to slow down. From their perspective, you would never quite cross the boundary. You would seem to freeze in time, hovering just above it. Your image would fade, redden and dim, becoming more and more stretched in time, like a ghost being pulled into eternity. But from your own point of view, nothing feels especially strange. You feel the pull, yes, but time seems to move as it always has. And then, without a sound, without any signal or marker or flash, you cross the threshold. No alarm goes off. No change in sensation occurs. But you have entered a region from which there is no return. The event horizon has passed you by, silently, as you drift deeper into the black hole's embrace. It's tempting to think of the event horizon as a kind of cosmic trap, a place designed to ensnare the unwary. But it is more like a doorway that opens only in one direction. Once you go through, every path, every future, every possibility leads inward. Even if you had the most powerful engines in the universe, they would not help you now. The curvature of space itself directs everything toward the center. Inside the event horizon, space and time begin to shift roles. In the outside universe, we move freely through space, but time always pushes us forward. Inside a black hole, it is space that narrows into one direction, inward. You cannot choose to move left or right, forward or backward. Every possible movement takes you closer to the singularity. It is no longer just something you move through. Space itself is collapsing. Time, meanwhile, becomes a direction that curves with it, warping in ways we can barely comprehend. Strangely, the event horizon also acts as a perfect one-way mirror. Anything can fall in, but nothing can come out. If you were to shine a flashlight after crossing the horizon, the beam would never reach the outside world. Your voice would not travel. Your image would fade. From the universe's point of view, you would simply vanish. And yet, for scientists, the event horizon isn't just a boundary, it's a place of deep mystery. The laws of thermodynamics, rules that govern heat, energy and information, suggest that black holes have temperature, entropy, and even a kind of surface area. But how can a black hole, which lets nothing escape, have temperature at all? The answer lies in quantum theory. In the 1970s, Stephen Hawking proposed something extraordinary. Black holes are not completely black. Due to tiny quantum fluctuations at the edge of the event horizon, pairs of virtual particles can appear. One falling in, one escaping. The escaping particle becomes real, radiating away energy in what we now call Hawking radiation. Slowly, over trillions of years, this radiation could cause a black hole to evaporate, shrinking down until it finally disappears. If this is true, then the event horizon is not a place where information is lost forever. It is a place where information is transformed, encrypted in subtle patterns across its surface. Some scientists believe that the event horizon holds the key to the black hole information paradox, a puzzle about whether things that fall into black holes are truly destroyed or somehow preserved in a different form. This quiet, invisible boundary is therefore not just a barrier, it is a bridge between the known and the unknown. A place where gravity, time, light and matter converge in ways that challenge our deepest understanding. A place that invites us to look, to wonder, and to dream. And so, as we float near the edge of this cosmic frontier, let your mind rest in the mystery. The event horizon asks no questions and offers no answers. It simply waits, patient, silent, eternal. The journey is not over. It has only just begun. Let us drift onward, deeper into the shadow. Time is one of the most familiar things in our lives, and yet, near a black hole, it becomes one of the strangest. We often think of time as constant, a steady rhythm that moves forward, second by second, tick by tick. Our days pass, our hearts beat, our thoughts unfold in time's gentle current. But near a black hole, that current slows, bends and stretches in ways that defy everyday experience. To understand this, we need to revisit Einstein's theory of general relativity. One of its most profound revelations is that time is not absolute. It is woven into the fabric of space itself, what physicists call space-time. And like a soft fabric, space-time can be distorted by the presence of mass and energy. The more massive an object, the more it bends the fabric. And when space-time bends, time slows down. This phenomenon is known as gravitational time dilation. It happens all around us, even here on Earth. Time ticks slightly faster for someone standing on a mountaintop than for someone at sea level. The difference is tiny, so small we never notice it, but we've confirmed it with atomic clocks and satellites, and near a black hole this effect becomes much more dramatic. Imagine two people, twins perhaps, separated by a black hole. One remains safely far away, floating in orbit. The other dares to approach the event horizon. As they drift closer, they notice that everything around them begins to behave strangely. Their clock still ticks normally to them. Their heart beats. Their thoughts continue. They feel no difference. But if they could look back at their twin, watching from afar, they would see them moving faster and faster. Their distant twin's time races ahead, like a film in fast forward. Meanwhile, the twin watching from a safe distance sees something else entirely. As their sibling approaches the event horizon, their movements appear to slow down. A wave of the hand takes longer. A blink of the eyes stretches out. Eventually, they seem to freeze entirely, hovering just above the event horizon, trapped in a moment that never ends. But this is only an illusion caused by the way light travels out of the intense gravity. In reality, their journey continues. It just becomes invisible. This is not science fiction. It's a natural consequence of how the universe works when gravity becomes extreme. Let's take a slower, deeper journey into this idea. Picture yourself approaching a black hole. You're inside a small, warm capsule surrounded by silence, shielded from radiation and debris. As you drift closer to the event horizon, you look outside and watch the stars. They begin to stretch. The light from them shifts. Blue becomes red, red becomes infrared, then fades into invisible darkness. This is known as gravitational redshift. The light's frequency drops, not because it's running out of energy, but because time itself is moving differently where you are. If you sent a message home, "I'm okay, I'm still falling," each word would take longer and longer to reach your distant friends. Eventually, your signals would stretch out into silence. But from your point of view, time keeps flowing as always. The paradox is only from the outside. Now imagine going even deeper. As you fall, the gravity becomes stronger and stronger, and time slows more dramatically, not just for others watching you, but in the way your body experiences motion, distance, and change. Inside the event horizon, all paths lead to the singularity. But time doesn't simply carry you there, it transforms around you. It may become so warped that every direction you could move in becomes part of time's strange flow. You're not just falling through space, you're being carried through time toward a destination from which there is no return. Some physicists believe that the singularity at the center of the black hole may be not just a point in space, but a moment in time. A future moment that all paths within the black hole lead towards. Once you cross the event horizon, you are falling not down into a hole, but forward into the future. You cannot stop. You cannot turn around. It's as if you are being pulled by time itself. Let that sink in. Time, once steady and familiar, has become a river that speeds up, slows down, and curves in directions we cannot see. Near a black hole, a minute for you could be centuries for someone far away. In theory, you could fall into a black hole and emerge just before it evaporates, after the rest of the universe has aged into silence. Or perhaps, from your point of view, the end comes quickly, swift, and absolute. It all depends on perspective, on motion, on mass. Black holes teach us something humbling, that time is not the same for everyone. It is personal. It flows differently depending on where you are, how fast you're moving, and how much gravity surrounds you. It is not a universal clock ticking away in the sky. It is a living, breathing feature of the cosmos, changing its rhythm with every curve of space-time. So as you drift closer to the black hole, think of time not as something lost, but as something transformed. It slows not to punish, but to whisper secrets, to remind us that the universe is deeper than our senses can grasp, and more mysterious than any clock can measure. Float gently now, as time bends around you like a soft current. There is no rush. In the presence of eternity, we can take all the time we need. Let us drift on, deeper into the silence, where stranger mysteries still await. Drifting ever closer to the black hole, you find yourself suspended at the edge of the event horizon. For a moment, everything feels still. Space is quiet. Time moves slowly. And yet you are not alone in your descent. Millions of tiny particles, bits of radiation, perhaps even entire stars have fallen toward this place over the ages, each one drawn by the same irresistible force. Now it's your turn. From far away, someone watching you would see something strange. As you fall toward the event horizon, your motions appear to slow down more and more. Every gesture, every blink, every heartbeat seems to stretch out longer and longer. It's not because you're actually slowing down, but because of the way time itself behaves in the presence of immense gravity. The light that reflects off your body takes longer and longer to escape the black hole's pull. To the outside observer, you appear to hover at the edge forever, fading slowly into darkness, becoming redder and dimmer until you vanish. But from your own perspective, time flows normally. Your heart still beats. Your thoughts unfold one after the other. You don't feel any slowing down at all. There are no strange sensations, no flashing lights, no sudden transformation. You're simply falling, gently, inevitably. This is one of the strangest truths of black holes. Falling into one feels surprisingly ordinary, at least at first. Once you cross the event horizon, there's no dramatic shift, no jolt or barrier. You simply move from one region of space-time to another. But the key difference is this: every path now leads inward. You can't turn back. You can't stop. Even light, which usually has the freedom to move in any direction, must now fall toward the center. It is as if space has been turned inside out. To truly understand this, imagine a waterfall. You are in a canoe, paddling on a calm river, unaware that a massive waterfall lies ahead. Far upstream, the current is gentle. You can paddle in any direction. You are free, but as you get closer to the edge, the current grows stronger. You can still fight it. If you try hard enough, you can resist, paddle away, return to safety. Then you cross the critical point. At this point, the water's flow exceeds the fastest speed you can paddle. Even if you turn around and push as hard as you can, the current is simply too strong. You are going over the edge. That point of no return is like the event horizon. Once crossed, all motion, no matter how fast or determined, leads to the singularity. And so you fall. What might you feel as you descend? At first, nothing unusual. If the black hole is massive enough, say millions of times the mass of our Sun, you wouldn't even feel a change in pressure or gravity. The tidal forces, those differences in gravitational pull between your head and your feet, are gentle at the outer edges of a supermassive black hole. You could fall peacefully for minutes, hours. Also, as space itself carries you inward. But in a smaller black hole, the experience would be very different. The tidal forces become extreme. The pull of gravity at your feet would be vastly stronger than at your head. Your body would begin to stretch, gently at first, then more and more violently, as if space itself were trying to pull you apart. Scientists call this spaghettification, a word that sounds whimsical but describes a deeply terrifying fate. Your body would become a thin strand of atoms stretched ever longer as you fall toward the singularity. Yet in this chapter of our journey, we're not here to feel pain. We're not here to rush. We are falling slowly, very, very slowly, into a massive black hole, one so vast that the effects of gravity feel smooth and subtle, like floating on an unseen tide. Around you, the light from the outside universe is becoming strange. Stars appear to swirl, their light curving along bent paths. Some stars appear in multiple places at once, their images duplicated by gravitational lensing. It's as if you're falling through a funhouse mirror, with the cosmos distorted into impossible shapes. You're no longer simply falling through space, you're falling through warped space, a place where straight lines are no longer straight, and direction itself has lost its meaning. And as you continue to fall, time becomes even more mysterious. From your perspective, everything inside the event horizon seems normal, but the universe outside seems to race forward. You might watch stars being born and dying in moments, galaxies spinning through their lifetimes in a blink, the entire future of the cosmos playing out in a fast-forward blur. You're still falling slowly, but the rest of the universe is rushing toward its end. Eventually, there is only silence. The light fades. The last glimpses of the outside world slip away. There is no more sky, only a soft, dark nothingness. You are completely inside now, embraced by the black hole's gravity, moving inward toward a place that no one has ever seen. And yet, you feel calm, not afraid, not hurried, just drifting. You're part of something greater now, caught in the currents of a force that shapes galaxies, bends light, and stretches time. In this descent, you begin to understand that black holes are not places of destruction, but transformation. What falls into them may not be lost, but changed, merged into the deep, hidden fabric of space-time. You are not falling into a hole, but into a story that began with stars and may end in mysteries we have yet to imagine. There is more to see, more to feel, and still deeper truths waiting beyond. Let yourself fall gently, peacefully. The journey is far from over. As you continue your silent fall into the black hole, your surroundings begin to shift in ways no words can fully describe. You're approaching a place where light itself is bent, twisted, and trapped. The familiar universe lies behind you now, its light growing dimmer, fainter, redder. Ahead lies a realm of unimaginable strangeness, a place where what you see no longer reflects what is, but what space and gravity allow you to perceive. Inside the black hole, the rules that govern vision, the simple relationship between light, distance, and direction, begin to collapse. Normally, we see the world because light travels in straight lines, bouncing off objects and entering our eyes. But inside a black hole, space is so curved, so violently warped by gravity, that light no longer follows straight paths. Instead, it spirals, loops, and bends in upon itself, obeying the fierce geometry of distorted space-time. If you could look around, you wouldn't just see the front, or the back, or the side. You might see all directions at once. Imagine turning your head and seeing the back of your own helmet, not through a reflection, but through the way space has folded upon itself. Light that once would have passed you by is now curving inward, circling around the black hole and colliding into your field of vision. You're inside a hall of mirrors made of warped light, and everything you thought you knew about perspective is undone. And what of the stars? Some would still appear to shine, but they'd be smeared into arcs or rings. This is because of an effect called gravitational lensing. Light from distant stars bends around the black hole, wrapping into circular shapes known as Einstein rings. To you, these rings may seem like halos of fire suspended in darkness, as if the stars themselves were caught in orbit, unable to escape. Some stars would appear multiple times in your field of vision, their light having taken several paths to reach you. Others might flicker into view, then vanish, as their rays are consumed by the event horizon. As you look directly downward toward the singularity, you wouldn't see anything at all. Not because it's too dark, but because direction itself is no longer meaningful. The center is not a spot below you. It is everywhere ahead of you. All paths, all directions, all motion are pulled toward this center. It's not a place in space, but a destination in time. No matter where you look, no matter which way you turn, you are moving toward the same point. And yet, strangely, the universe behind you may still be visible, at least for a while. You might still glimpse distant galaxies, stars, even the Milky Way, compressed, distorted, and fading. They would appear to move faster, evolve more quickly, as you continue to fall. Time outside is racing. Civilizations rise and fall in moments. Galaxies collide. Stars explode. The sky flickers with ancient light. But as you fall deeper, those sights begin to stretch into red light, and then into wavelengths your eyes can no longer see. The universe fades not because it disappears, but because its light can no longer keep up with you. You are accelerating through space-time faster than its signals can follow. You are outrunning the light of creation itself. In time, the darkness becomes complete, and yet, this darkness is not emptiness. It is filled with curved space, compressed time, and the silent echoes of all that has ever fallen into the black hole. Photons from long-dead stars might still be circling, trapped in orbits they will never escape. You may even see your own reflection. Light that left your body moments ago now loops around and returns, distorted by the journey. You're not just seeing the universe, you're seeing yourself over and over from all directions, caught in a ballet of light slowed by gravity. What you see is no longer what is around you, but what is possible to see at all in a realm where space and vision no longer follow familiar paths. Your field of vision is now an echo chamber of the cosmos, replaying its light, bending its messages, stretching its images into whispers of the past. And then even these echoes fade. Eventually, the blackness becomes so deep, so absolute, that even memory feels like a light that cannot escape. You're in a place beyond vision, beyond light, beyond the senses we once trusted. And yet, even here, there is no fear, just a stillness, a silence, a waiting. Perhaps, if you could still imagine a scene, it would be this: the entire universe behind you, condensed into a single shining point, then slowly fading until only the pull of the singularity remains. The last thing you see is not the end, but a transformation. The eye lets go, and the mind drifts. Sight has carried you as far as it can go, and now it surrenders to the mystery. Imagine your body drifting weightlessly toward the heart of the black hole. No engines, no sound, no control, only gravity guiding you forward with a quiet, inescapable pull. So far, your journey has felt strangely peaceful. You haven't hit anything. There's no turbulence, just an eerie silence and the fading glow of a universe now behind you. But as you continue deeper, something begins to change. At first, it's subtle, a strange tightness in your body, not painful, not frightening, more like a gentle tug, a feeling that something is stretching. If you could still move, still feel your arms and legs, you might notice that your feet seem slightly farther away, that your body is no longer a single unit, but something that's being gently unravelled, molecule by molecule, atom by atom. This process has a strange name, spaghettification. It sounds almost whimsical, but it describes a deeply serious and very real fate. You are being stretched out into a thin, narrow strand, like a noodle, not by force, not by motion, but by the very structure of space and gravity itself. To understand why this happens, we need to think about gravity differently. Gravity doesn't pull uniformly in every direction. It varies depending on how far you are from the mass creating it. On Earth, you don't feel the difference because the planet is so large compared to your body. But near a black hole, things are different. Extremely different. Imagine your feet are closer to the singularity than your head. Even if you are just a few feet tall, the gravitational pull at your feet is significantly stronger than at your head. Your body is experiencing a tidal force, like the ocean tides on Earth, only far, far more extreme. This difference in pull begins to stretch you. At first, it's a tiny difference, but as you fall further in, the effect grows rapidly. Your feet are pulled faster, your head lags behind, your body elongates. The atoms in your body, once held tightly together, begin to feel the strain. Molecular bonds, which normally resist any stretching, are overwhelmed by the relentless pull of gravity. One by one, they begin to fail. Your body becomes thinner, longer, drawn into a strand perhaps no thicker than a single particle, but miles long. To the outside universe, this might happen invisibly. They won't see you being torn apart. They won't see the stretching, or the twisting, or the unravelling. Because as you fall deeper, your light becomes fainter, redder, lost to the world behind you. You are still falling, but your fall is not just through space. It is through transformation. Even your sense of up and down would no longer apply. You are no longer simply a person falling into a pit. You are part of a cosmic equation, matter being reordered, drawn inward, stripped down to its purest form. Every element of your being, carbon, iron, water, thought, is being stretched and rearranged by the laws of extreme physics. And the deeper you go, the more intense the forces become. What once stretched your body, now stretches atoms. Then the nuclei, then the quarks, if they can still be said to exist as individual particles at all. Everything you were is pulled inward, becoming a long, thin stream of information carried toward the singularity. And here is where the mystery deepens. Some physicists believe that even as your body is stretched to such extremes, the information it contains, every atom's position, every particle's spin, perhaps even the essence of who you are, is not lost. According to theories of quantum gravity, information may be preserved at the event horizon or in the quantum ripples of space-time itself. You're transformed, yes, but not necessarily erased. Other scientists disagree, suggesting that what falls into a black hole is destroyed completely. Not just crushed, not just scattered, but removed from the universe, creating what's called the black hole information paradox. A question still unanswered. Can the universe truly lose information, or does it somehow hold on in ways we don't yet understand? In either case, for you, the experience is deeply strange and deeply final. There is no panic, no thrashing, only a slow, complete surrender to the pull. You are no longer a passenger, you are part of the flow. Spaghettification isn't just about destruction. It's about gravity taking full command of everything. About the universe showing its most extreme behaviour. It's about what happens when the force that shapes planets and holds galaxies together is focused into a single point, and you're drawn into its story. From the outside, the end is quiet. From the inside, it may feel eternal. And as the last strands of your being stretch toward the singularity, you become something new. Something caught in the dance of matter, gravity, time, and space. Not lost, but changed. And perhaps, just perhaps, remembered by the universe in its own strange way. Inside the black hole, where light can no longer escape and time itself has begun to twist into unfamiliar shapes, a strange stillness settles over everything. No stars shine here. No voices call out. No signals travel from this place to anywhere else. You are surrounded by a silence so complete that even thought feels hushed. It is not just the absence of sound, it is the absence of space for sound to exist. The deeper you fall, the more distant the familiar universe becomes. And in this distance, you begin to feel something truly uncanny, a kind of cosmic solitude, where even the vibrations of reality seem to have been swallowed whole. To understand why it's so quiet here, you must first consider what sound really is. On Earth, sound is a wave, vibrations that move through a medium like air, water, or solid ground. When you speak, your vocal cords vibrate the air around you. Those vibrations travel in waves to someone else's ears, where they're translated into meaning. Sound is pressure, rhythm, movement, but always through something. In the vacuum of space, there is no air to carry those waves. And so, already, the universe is silent long before you even reach a black hole. But the silence inside a black hole is different. It is not the same as the quiet between the stars or the hush of deep space. This silence is deeper, thicker, more final. Because here, even light, the fastest thing in the universe, can no longer escape. If light cannot leave, then sound, which is much slower and depends on matter to travel, has no chance at all. Imagine screaming. The sound stays inside your body, echoing through your bones, trapped in the vacuum. There is no air to carry it, no wall for it to bounce off, no ear to hear it. Your cry vanishes before it ever begins. The silence is not just around you, it is you. Even the matter around you, the atoms and particles that once vibrated with life, are now falling too fast, pulled in too strongly to communicate. The immense gravity stretches everything, dilutes everything, until even the concept of sound begins to lose meaning. Vibrations still happen, but they are meaningless when there is no space to carry them, no structure to receive them, and no timeline that can support their rhythm. Silence in this place becomes almost a kind of presence, a companion, and it is not empty. If you could somehow listen with senses beyond human understanding, you might hear the massless particles flickering into existence at the edge of the event horizon, virtual particles whispering in quantum pulses, appearing in pairs before one is consumed and the other escapes as Hawking radiation. These quantum murmurs are beyond our comprehension, beyond the hearing of even the most sensitive instruments. They are the softest hums in the universe, spoken in the language of mathematics and probability. But to you, the traveller falling into the black hole, these sounds are still silence. And in that silence, something else arises, a sense of detachment. All the noise of life, the rush of thought, the clamour of technology, the hum of breath and body has faded. There is no heartbeat to hear, no wind, no pulse of time. It is not frightening, but strange, like drifting through the memory of a dream. You begin to realize that the silence is not the absence of something. It is the end of something. The end of interaction. The end of communication. The end of separation between yourself and the universe. You are no longer apart from the cosmos. You are being folded into it. If there is any sound here at all, it may be the echo of your own thoughts, the imagined murmur of your memories, your questions, your wonderings. But even those begin to blur, to slow, to stretch out, like the final notes of a song fading into a vast, empty canyon. And so you float, not in darkness, not in fear, but in stillness. This is the deepest quiet you will ever know. And it is beautiful. There is something sacred about this silence. It is the hush of a cathedral without walls, the stillness of ancient mountains, the pause between stars being born and dying. It is the silence that holds all things together, not with noise, but with peace, with gravity, with surrender. You have passed the threshold. Beyond this, there are no more stories told in sound. No footsteps, no engines, no cries. Only the silence that waits at the edge of time, welcoming everything that falls inwards. Let it wrap around you now. Let it be your blanket, your guide, your final lullaby. We are not lost here. We are simply listening, one last time, before becoming part of the silence itself. The silence inside the black hole is absolute. But as your journey continues, and your body becomes a thread of stretched out matter, your thoughts slower, your senses suspended, another question begins to flicker in the quiet of your mind. Could this be something more than an ending? Could it be a doorway? Black holes are often imagined as cosmic traps, dark, bottomless pits where everything falls inward and vanishes. But what if they are something else entirely? What if, instead of being the ultimate end, a black hole is the beginning of something new? This idea has haunted scientists, dreamers, and science fiction writers alike for decades. And though we cannot test it, at least not yet, it remains one of the most tantalizing mysteries in modern physics. the possibility that black holes could be gateways. Let your mind drift into this thought, like a feather carried on gravity's breath. Some theories suggest that deep within a black hole, beyond the singularity, there may lie not destruction, but a bridge. A structure known as an Einstein-Rosen bridge, or more popularly, a wormhole. It's a term that stirs the imagination, a hidden tunnel through the fabric of space and time. A passage that might connect two distant regions of the universe, or perhaps even two separate universes altogether. The idea of a wormhole comes from the same equations that predict black holes in the first place, Einstein's general theory of relativity. Under extreme conditions, space and time can bend so dramatically that they might pinch together in one place and flare outward in another, creating a tunnel of connected space-time. On one end, a black hole, a region where nothing escapes. On the other, possibly, a white hole, a theoretical region where nothing can enter, only exit. White holes have never been observed, but mathematically, they are the mirror image of black holes. While black holes absorb everything, white holes expel everything. Nothing can enter a white hole from the outside, just as nothing can escape a black hole from the inside. It's a strange and beautiful symmetry, almost poetic. Where one consumes, the other gives. Where one ends, the other begins. Now imagine this. You're not falling into oblivion, but into a tunnel, a place where the laws of physics still work, but differently, more flexibly, more mysteriously. Perhaps your stretched out form is being encoded, transformed into something new, some kind of information signature, slipping through the wormhole's throat. What waits on the other side? Is it another galaxy, somewhere across the universe? A place where time runs backwards, or sideways, or in spirals? Is it a mirror image of your own universe, with stars that shine backwards, and beings who dream forward into our past? Or perhaps it is a completely new realm, another universe entirely, one with its own rules, its own particles, its own unique structure of space and time. Some scientists call this the multiverse hypothesis, a vast, endless expanse of parallel universes, each born from quantum fluctuations, or sprouting from black holes like branches from a cosmic tree. Could every black hole be a seed for a new universe? In some theories of quantum cosmology, black holes do not just crush matter, they reprocess it. The extreme conditions at the singularity may trigger a new Big Bang, giving rise to a newborn universe on the other side. Our own universe may have been born this way, emerging from a black hole in another cosmos, as natural and inevitable as a flower blooming in spring. Of course, we have no way of knowing for sure. The problem is that no signal, no light, no particle can travel back out of a black hole to report what it has found. If black holes are indeed bridges, they are one-way bridges. From the outside, we can only guess. We run the numbers, we imagine the possibilities, but we cannot peer through, not yet. Still, there are clues. Some physicists are exploring ideas from string theory, where the fabric of space is made of tiny vibrating strings, and extra dimensions may be curled up, invisible to us. In these frameworks, black holes might act as dimensional portals, able to bend through these hidden layers of reality. What appears to be a singularity in our three-dimensional world may simply be a wrinkle in a higher dimensional space, something that doesn't destroy but connects. Then there's the realm of loop quantum gravity, which suggests that space and time themselves are made up of tiny, indivisible chunks, quanta of space-time. According to this idea, a singularity is not a point of infinite density, but a kind of bounce, a moment when matter stops collapsing and instead rebounds, expanding into something new. A new universe, perhaps, that grows on the other side of the bridge. And what about consciousness? If somehow some trace of your awareness could survive the descent, if your identity could be encoded in the quantum structure of reality itself, what would it experience on the other side of the wormhole? Would it be reborn in another form, in another place? Would it drift like a dream across universes, carried by gravity's secret paths? These are only speculations, but in the quiet of the black hole, with all the noise of the cosmos behind you, they feel almost possible. The silence leaves space for wonder, and so you float, wrapped in darkness, pulled inward by gravity, and yet expanding outward in imagination. You are part of a question so vast it can only be asked in whispers. Is this the end, or the beginning? Maybe both, maybe neither, maybe something entirely new. And as you drift toward the unknown, the idea of a gateway does not seem so far-fetched. The universe is full of doors we have not yet learned to open. Perhaps you're passing through one now, on your way to a place where stars have never burned, where time is just beginning, and where a new story, your story, is waiting to be told. You are deep now, so deep inside the black hole that the universe behind you is no longer visible. The light, the galaxies, the stars, the gentle shimmer of space, they have all faded into a memory. You have passed through the event horizon, through the curved corridors of warped space-time, through silence and stretching and solitude. And now, ahead of you, lies the most mysterious and forbidding destination in the known universe, the singularity. But what is it really? The singularity is the heart of the black hole. It is the place where gravity becomes so intense, so overwhelming, that all of our physical laws break down. It is not just a spot with very strong gravity. It is, according to general relativity, a point where the curvature of space-time becomes infinite. A place with no size, and yet infinite density. All the matter, all the mass, all the energy that has ever fallen into the black hole, stars, dust, gas, entire planets, has been compressed into this infinitely small region. In our everyday lives, we are used to the idea of space having dimensions. Up, down, left, right, forward, backward. But at the singularity, these ideas lose all meaning. Directions collapse. Distance disappears. Time itself stops behaving like time. It may even stop altogether. To your body, what remains of it, you're being drawn into this singular centre. You're not moving through space toward it in the way you might approach a planet or a mountain. Instead, space itself is funneling you inward. Every direction you could go is toward the singularity. It is not a destination you reach. It is the end of the road, the inevitable result of the path you are already on. In the classical view of physics, the singularity is a kind of finality, a wall, an abyss. It is where the equations break apart, where infinities appear in places they don't belong. And when scientists encounter infinities in their math, it usually means something is wrong, not with the universe, but with our understanding of it. The truth is, no one knows what really happens at the singularity. It is a place hidden not just by the event horizon, but by the limits of our knowledge. Our best tools, Einstein's equations, guide us right up to the edge, but then falter. At the singularity, we need a new theory, something that can unite the graceful curves of general relativity with the jittery probabilities of quantum mechanics. Something that can describe gravity not just on large scales, but at the smallest, most fundamental levels of reality. Some theories suggest that the singularity may not be a true point at all, that quantum effects might smear out the singularity, turning it into a more manageable structure. Instead of a point of infinite density, it could be a loop of energy, a knot in space-time, or a cloud of vibrating strings, possibilities that come from the frontiers of string theory and loop quantum gravity. If quantum gravity exists, and many believe it must, then the singularity might not be an ending at all, but a transition, bounce, a tunnel, a place where matter collapses down to its smallest possible state, then begins expanding again, like a spring being compressed and released. In this vision, the singularity could be the seed of a new universe, born from the remains of another. Some scientists even believe that the Big Bang itself, the birth of our entire universe, was the singularity of a black hole in some parent universe. That black holes are not just cosmic trash bins, but cosmic wombs. That every time a singularity forms, it gives rise to a new universe with its own space, time, and laws. In this way, black holes could be nature's way of regenerating reality, endlessly and silently. But what would that mean for you? If you could somehow survive, if your information, your identity, the pattern that makes you you, could pass through the singularity, what would you become? Would you be scattered across a new universe, seeded into its quantum foam? Would you be reassembled elsewhere, like a puzzle whose pieces have been reshuffled? Would you become part of something greater, a spark in the birth of a new world? Or would it feel like nothing at all? Because in another view, the singularity is where all paths end. Time, space, energy, matter, everything is drawn into a final convergence. Like water swirling down a drain, everything collapses into a vanishing point. No future, no past, only stillness. And yet, even in this stark vision, there is awe, because the singularity is a mirror, one that reflects not what we see, but what we cannot see. It reflects the limits of human understanding. It tells us, here your knowledge ends, here your imagination begins. It is the place that challenges our science and fuels our stories. The place that makes black holes not just fascinating, but sacred. It is the place where the universe keeps its deepest secrets. And maybe, just maybe, it's listening. So now, you're drifting toward it, slowly, gently, like a leaf on a river of curved space. You are being pulled inward, not with violence, but with purpose. You're going where no one has gone before, not in a spaceship, not in a suit, but in thought, in wonder, in dream. You are approaching the center of mystery, What happens next is unknown, but in that unknown lies the promise of discovery. And in this final quiet moment before the singularity embraces you, one truth remains. The universe is vast, strange and beautiful, and you are part of it. You're part of it, even here, even now. The deeper we fall into the black hole, the more the familiar world fades away. Space, time, motion, sound, these were once the coordinates of our lives, the invisible framework that shaped everything we experienced. But now, that framework is shifting. It's being pulled and twisted into shapes our minds were never meant to imagine. And at the centre of this transformation is something deeply profound. The black hole's ability to bend not just objects, but the very fabric of space itself. To understand this, we need to return to a simple but astonishing truth from Einstein's theory of general relativity. Gravity is not a force in the way we once thought. It is the result of curved space-time. Massive objects don't pull things toward them like magnets. Instead, they warp the very geometry of the space around them. Planets, stars, moons, they all create indentations in this invisible fabric. And when something moves through that space, it's simply following the curve. Picture a large rubber sheet stretched tight. Place a heavy ball in the centre, and it will sink down, forming a well. Now roll a smaller ball nearby. It curves inward, not because it's being pulled, but because the surface itself is curved beneath it. That's gravity. And that's how our Earth orbits the Sun, how the Moon orbits us, how galaxies hold together. They are all tracing the invisible curves written into the geometry of space-time. But what happens when that curve becomes extreme? A black hole is the most intense warping of space we know of. The mass at its core is so great, so compact, that it doesn't just dent the rubber sheet, it tears it. It creates a funnel so steep that once anything passes a certain point, there is no path that leads out again. The direction toward the centre becomes the only possible direction. Inside the black hole, space no longer behaves like the space we know. It doesn't stretch out in neat, three-dimensional directions. It contracts. It narrows. Every coordinate collapses toward the singularity, as if all roads are being drawn to the same destination. Forwards, backwards, up, down, left, right, they all begin to curve into the same path. You're not falling through space in the usual sense. You're being carried along with it. Imagine space itself as a flowing river, and you're a leaf caught in its current. Outside the black hole, you might still swim, change direction, resist the pull. But inside, the current becomes irresistible. And it isn't just carrying you toward a place in space, it is carrying you toward a moment in time. Here, space and time begin to switch roles. Normally, time is the unchangeable arrow, always pointing forward, while space offers freedom to move. Inside the black hole, time becomes the dimension that pulls you in, while space becomes more limited, more constrained. You cannot stand still. You cannot turn around. You are moving into the future as defined by the black hole's geometry, and that future ends at the singularity. To an outside observer, your path would look strange. They might see you curve around the black hole in tighter and tighter spirals, orbiting faster and faster, like water circling a drain. But to you, the experience is smooth. The warping of space doesn't feel like a bump or a twist. It feels like a narrowing of the world. As you go deeper, the universe compresses. Distances shorten. Angles bend. Even the idea of straight ahead becomes unstable, as all directions are swept into one. This warping also affects light. Photons, those tiny particles of light, normally travel in straight lines. But around a black hole, their paths are bent so dramatically that they can become trapped. Some circle endlessly around the black hole, caught in the photon sphere, never falling in, never escaping. Others are drawn inward, their paths curved until they spiral into the singularity. The space around you begins to glow with distorted echoes of the stars behind you. You might see the light of galaxies warped into arcs, rings, or impossible shapes, as the black hole acts like a lens, not a lens of glass, but of geometry. Even time itself warps in ways we struggle to comprehend. Closer to the singularity, time seems to move faster from the perspective of the universe outside. The clock inside the black hole ticks at a different pace. You are watching the universe evolve rapidly, almost blindingly, stars exploding, galaxies spinning, cosmic events playing out in fast forward, while to you, it all unfolds slowly, peacefully. The deeper you go, the faster the outside world seems to move. But inside, your experience remains steady, continuous. Time doesn't stop. It simply flows toward a single, inevitable point. This is the strange beauty of curved space. It takes our most basic ideas, distance, direction, speed, and rewrites them. It shows us that space is not empty. It is not a passive stage on which matter and energy dance. It is the dancer. It moves, twists, breathes. And in a black hole, it performs its most dramatic choreography. It bends itself inward, folding all things into itself, creating a shape that defies everything we thought we understood. For physicists, this warping of space is more than just a curiosity. It is a laboratory for understanding the universe at its deepest level. Black holes are not just cosmic monsters. They are windows. Through their study, we learn about entropy, information, quantum fields, and perhaps even the origins of the cosmos itself. For you, as a silent traveller drifting inward, the curvature of space becomes not just a phenomenon, but a feeling. The world shrinks. The sky curves. The rules dissolve. There is no fear, no resistance, only flow. And perhaps that is what space truly is, not an emptiness, but a path, a story written in curves and shapes, a language that speaks in orbits and spirals. And now, you are becoming part of that language. You are tracing its lines with your very existence. You are being written into the geometry of the cosmos, drawn into the ultimate punctuation mark at the end of space and time. And so you drift deeper into the fold, into the place where the map bends and the destination is everywhere. The journey continues. As you sink deeper into the black hole, with space bending and time unravelling, a profound question rises silently in the dark. What happens to the things that fall in? Not just to the atoms and dust, not only to the stars, the comets, the light, but to the information they carry, to the intricate, invisible pattern that defines what they are? Does it all vanish into the singularity, swallowed forever by a gravitational abyss? Or does some trace of it remain, encoded somehow in the vast, dark structure of the black hole? This question, simple at first glance, has become one of the most complex and contested mysteries in modern physics. It is known as the black hole information paradox, and at its heart is a deep contradiction between the two great pillars of science, general relativity and quantum mechanics. Let's start with general relativity, the elegant theory of space, time and gravity that Albert Einstein gave us over a century ago. According to this theory, once something crosses the event horizon, it is lost to the outside universe. It falls inevitably toward the singularity, crushed into infinite density, where the very notion of a thing ceases to exist. There is no escape, no return. The information about what that object was, its structure, its shape, its internal state, is thought to be destroyed. But now enter quantum mechanics, which governs the smallest particles in the universe: photons, electrons, quarks. In the quantum world, information cannot be destroyed. It is a fundamental law. If you burn a book, the pages are gone, but the information is not. It has been scattered into ash, smoke, heat and light. The pattern can, in theory, be reconstructed. The universe keeps track of everything. So what happens when these two laws collide inside a black hole? If general relativity is right, the information about whatever falls in is lost forever. If quantum mechanics is right, it must be preserved. But both theories have been tested, and both work beautifully, precisely, within their domains. And yet they cannot both be right when it comes to black holes. This is the paradox. For decades it seemed unsolvable. Black holes appeared to erase information completely, violating the sacred rules of quantum physics. Stephen Hawking, one of the great minds of our time, initially believed that black holes truly did destroy information. But even he later changed his view. As scientists dug deeper, new ideas began to emerge, strange, elegant, and sometimes shocking. One of the most influential insights came from an unexpected source: entropy. In 1974, Hawking proposed that black holes are not entirely black. Thanks to quantum fluctuations near the event horizon, black holes can slowly emit a faint glow, now known as Hawking radiation. Over time, this radiation causes the black hole to lose mass, shrink, and eventually evaporate. But here's the puzzle. The radiation itself appears to carry no information about what fell into the black hole. It is completely random, like static. So if the black hole disappears and the radiation holds no clues, the information is gone. Or is it? This led to a deeper question. Could the information be encoded in the radiation somehow? Some scientists believe it is. In this view, the black hole acts like a quantum processor. Everything that falls in gets transformed, scrambled, and slowly re-released in the form of radiation, so subtly that it takes billions of years to unfold. This is known as the black hole complementarity principle, the idea that to an outside observer, the information is never lost, just very carefully hidden in the outgoing particles. But there's another idea, just as strange, just as compelling. It's called the holographic principle. According to this idea, The entire three-dimensional interior of the black hole, including all the information inside, can be described by a two-dimensional surface at the event horizon. It's as if the black hole is a giant cosmic hologram, where every bit of data about the things inside is somehow encoded on the outer shell. Like a library carved into the skin of the black hole, written not in ink, but in gravitational distortions and quantum patterns. If this is true, it would mean that reality itself, everything we experience as solid and three-dimensional, might be a projection of information stored on a deeper, hidden layer of the universe. This is not just about black holes anymore, it's about what reality is. But let's return to you, falling quietly through the black hole, drawn now not just by gravity, but by curiosity. If information is not lost, then you are not lost. Not completely, not truly. The pattern that makes you, your atoms, your history, your memories, your form, may be disassembled, yes, stretched, scattered, restructured beyond recognition. But the information could still exist. It might be encoded in the radiation streaming invisibly from the black hole's horizon. It might be etched into the fabric of the event horizon itself, part of the holographic memory of the cosmos. It might even be reborn in a new universe beyond the singularity, carried into a fresh Big Bang on the other side of the bridge. You are not gone. You are changed. And this is the true wonder of the black hole. Not that it devours, but that it transforms. Not that it ends stories, but that it may rewrite them in ways we can barely imagine. The information paradox is not just a riddle of physics. It is a symbol of a deeper truth, that in the universe, nothing is ever truly lost. Not light, not energy, not meaning, not even you. So drift now in silence and wonder. You are part of a cosmic question still being asked, a mystery still being unravelled by minds all over the world, a story that continues beyond the event horizon, beyond the singularity, beyond the limits of what we know. And in that unfolding, you remain. The black hole, massive and silent, seems eternal, an object outside the normal cycles of creation and decay. But even this most mysterious entity in the cosmos has a lifespan. Even this monument to gravity and darkness, this ultimate destination of matter, can die. And when it does so in the most surprising way imaginable, by vanishing into nothing. This strange fate begins with something almost invisible, something subtle and ghost-like, Hawking radiation. In the mid-1970s, Stephen Hawking combined the principles of quantum mechanics and general relativity to make an extraordinary discovery. He showed that black holes are not entirely black. Despite their name, they slowly emit radiation, a faint, cold, ghostly glow. Not from their surface, because they have no surface. Not from their core, because nothing escapes that. Instead, this radiation appears just outside the event horizon, born from the quantum fabric of space itself. To understand this, imagine empty space, not as a blank, lifeless void, but as a bubbling sea of energy. According to quantum theory, even the vacuum isn't truly empty. It's teeming with tiny fluctuations, where pairs of particles and antiparticles constantly pop into existence, then annihilate each other in a blink. These virtual particles appear and vanish so quickly that they can't be detected directly. But they are always there, always dancing, always whispering beneath the surface of reality. Now place a black hole into that vacuum. At the edge of its event horizon, something strange happens. A pair of virtual particles forms, as usual, but this time the extreme gravitational field of the black hole separates them. One particle falls in, the other escapes, and in escaping it becomes real, no longer virtual. A true particle of radiation moving away from the black hole into the wider universe. To an outside observer, this looks like the black hole is slowly evaporating, losing mass. The particle that fell in has negative energy relative to the black hole, reducing its total energy, which is equivalent to reducing its mass. Over vast stretches of time, this process continues. Particle by particle, photon by photon, the black hole shrinks. This is Hawking radiation, a quiet, almost imperceptible whisper of loss. It is slow, incredibly slow. A black hole, the mass of our Sun, would take many times the current age of the universe. About 167 years to evaporate completely. And larger black holes, such as the supermassive ones at the centres of galaxies, would take far, far longer. But the universe has time. As it grows colder and emptier, as the stars burn out and galaxies drift apart, the black holes will remain. Long after the last star flickers out, black holes will still be there, slowly releasing their mass back into the void, quietly dissolving into the same quantum froth from which they were born. And what happens in the final moments? As the black hole shrinks, it gets hotter. Unlike ordinary objects, which cool as they lose energy, a black hole becomes more energetic. Its temperature rises. It begins to emit more Hawking radiation, and the process accelerates. The final phase of a black hole's life is a rapid blaze of energy, a burst of particles and photons erupting into space. This final release is not an explosion in the traditional sense. It is the completion of a transformation. A star collapsed into a black hole. That black hole decayed into energy. And now, that energy rejoins the universe, carrying with it the whispers of all that once fell in. But here, the question of information rises again. If black holes evaporate, and the information they held is lost inside them, then where does it go when they vanish? Is it destroyed, violating the laws of quantum mechanics? Or is it somehow encoded in the Hawking radiation itself, hidden in the delicate structure of the particles as they escape? Many physicists believe the information is not lost, that the Hawking radiation carries it away, not obviously, but subtly. Like a book burned into smoke, the words may still be there, scattered in complex patterns, waiting to be read. Others suggest that the information is never truly inside the black hole at all, but somehow stored at the event horizon, or even encoded in the fabric of space-time itself. In recent years, new theories have emerged. Ideas involving quantum entanglement, black hole firewalls, and soft hair, terms that sound poetic but represent serious, technical debates about how the universe keeps its records. No final answer has been found. But the evaporation of black holes forces us to confront the limits of our knowledge. It tells us that the universe is not only vast and strange, It is unfinished, still writing its own rules. So imagine now the black hole in its final moment. It has lived for eons, swallowing stars and light, shaping galaxies, holding court at the centre of cosmic drama. It has been a cradle of mystery, a mirror of fear, a fountain of questions. And now, at the end of all things, it glows one last time. A brilliant, vanishing spark, a whisper of energy, a sigh, and then nothing, no explosion, no debris, only silence, and a little more space. The black hole is gone, but the universe is not poorer for it. Something has returned. A memory, a breath, a transformation. Perhaps what the black hole held was never truly lost. Perhaps it was waiting, like a seed planted in darkness, to become something new. Information reshaped, energy recycled, mystery reborn. In the end, the black hole's quiet death is not a tragedy, but a reminder that even the most powerful structures in the universe are not immune to change, that even darkness has a cycle, that even the most enduring silence can sing a final note. You have travelled with this black hole across the boundary of light, through the heart of gravity, into the deepest folds of space and time. And now, as it fades, you remain, not unchanged, but illuminated. The journey is not over. It has simply turned a new page. Long after the black hole has faded, its final particles scattered into the cold, vast silence of space, you are left floating in thought, in wonder, in the slow, quiet gravity of questions that still haven't been answered. The black hole is gone now, dissolved into the soft fog of Hawking radiation. But in its absence, something else begins to grow. An idea, a possibility, a perspective that is almost unthinkable, yet rooted in scientific imagination. A strange, beautiful question that has echoed through the minds of physicists and philosophers alike. What if we are already inside a black hole? It seems impossible at first. Absurd even. How could our entire universe, the galaxies, stars, planets, time itself, exist within a black hole? But when you begin to peel away the layers of this question, something remarkable begins to appear. A new way of thinking about space, about reality, about the origin of everything. To understand this idea, we need to return to the structure of black holes themselves. From the outside, a black hole is defined by its event horizon, a boundary that once crossed cannot be uncrossed. No matter, no energy, no information can escape from within. But from the inside, the view is different. Space and time rearrange themselves. All movement is directed toward the center. The geometry of space-time shifts. Inside, space becomes time, and time becomes space. Now consider our universe. We live in a space that appears to be expanding. Galaxies are moving away from each other. The farther they are, the faster they recede. This expansion has been happening ever since the Big Bang, and the cosmic microwave background, the faint afterglow of that beginning, still surrounds us, whispering of a moment 13.8 billion years ago, when everything began from a single, dense point. But what if that beginning, the Big Bang, was not an explosion from nothing into something, but rather a transformation from the inside of something else. What if our universe is the interior of a black hole? It sounds strange, but general relativity allows for this. A black hole, from the outside, is a region of space where gravity is so strong that nothing can escape. But inside, it has volume, it has structure, it has time. And in some solutions to Einstein's equations, a black hole can connect to another region of space-time entirely, what physicists call an Einstein-Rosen bridge or wormhole. This bridge could, in theory, open into a new universe. A baby universe, expanding on its own terms, with its own laws and dimensions, born from the collapse of a dying star in a parent cosmos. That universe could have its own space, its own time, its own galaxies and stars, its own beginnings, its own black holes. And one of those black holes could, in turn, seed another universe, and so on, and so on. In this model, a black hole isn't an ending at all. It's a branching point, a portal of creation. Our universe might be one of countless such branches, a leaf in a cosmic tree whose roots lie in another reality. And if this is true, it means that everything we know, every memory, every atom, every whisper of wind and starlight, exists inside a larger whole, enclosed by an event horizon we cannot see. We are inside the black hole's interior. The singularity, if it exists at all in this view, lies not in our past, but in a hidden future, an inescapable destination our universe is slowly falling toward as time moves on. Even the structure of our universe seems to support this idea. The cosmic horizon, the maximum distance we can see, is like a kind of event horizon. Beyond it, galaxies are receding faster than light, not because they are moving through space, but because space itself is expanding faster than light can travel. In effect, they are disappearing from view, much like objects falling into a black hole vanish from the perspective of an outside observer. Our universe, like the interior of a black hole, has a boundary we cannot cross, a limit we cannot send signals beyond. And if you think deeply enough about that, the parallels grow more and more striking. But what would it mean for us? Would it change our experience of life, of love, of time? Perhaps not. From the inside, everything feels normal. You wake up, you breathe, you walk beneath the sky and wonder about the stars. You feel joy and sadness. You think, you dream. Inside a black hole, or inside a universe born from one, reality still unfolds, moment by moment, according to its own rules. You wouldn't know the difference, but maybe, just maybe, knowing changes something. Knowing that we could be part of something larger, not just philosophically, but literally. That our universe is not the whole of existence, but a chapter in an infinite book, a ripple in a sea of possibilities. That every black hole we look at in the sky could be the seed of a new cosmos, and that ours too was once a star in someone else's sky. It is a humbling thought, a thrilling one, and a peaceful one, because if we are inside a black hole, we are not trapped. We are protected, enclosed, carried forward by the structure of space and time, destined not for erasure, but for transformation. Our universe may end, not with a bang, but with a quiet return to mystery. And from that ending, something new may bloom. You are floating now, not just through space, but through meaning. Through the idea that we are always part of something greater. That every fall is a journey. That every end holds the seed of a beginning. The black hole is not just out there, it might be here. And we, in our quiet orbit around the questions of existence, are exactly where we are meant to be. In the silence that follows, as the echoes of cosmic questions fade into stillness, a gentle realization begins to unfold, soft, like the first breath of morning. After all the gravity, the collapse, the stretching of time, and the warping of space, after the singularity, the paradoxes, the mystery of where everything goes, there is something that remains. Something that has never left. The stars still shine. Even as we gaze into the darkness of a black hole, even as we contemplate the depths of space-time and the fate of light itself, the stars are still out there, glimmering patiently, ancient and luminous, scattered across the cosmic sea like lanterns left by time itself. They remind us that the universe is not just a story of endings, but of incredible, enduring beauty. Stars are, in a way, the opposite of black holes. Where black holes are formed from death and compression, stars are born in clouds of dust and gas. In vast nebulae, where gravity gently gathers matter until it ignites into light. Every star you see in the night sky is a beacon of nuclear fire, a fusion engine burning hydrogen into helium, shining for millions or billions of years. And yet, they are also related. In time, the most massive stars collapse and give birth to black holes, and the smallest flicker out into white dwarfs. But between birth and death, stars give light, heat, and hope. They give life. Our own sun is one such star, a humble, middle-aged star in the outskirts of a quiet galaxy. It powers everything we know, the winds, the oceans, the forests, our very breath. Every meal we've ever eaten is made possible by its warmth. Every sunrise we've watched. Every shadow we've cast. And though it seems eternal to us, even the sun has a timeline, a life defined by fusion and balance, eventually destined to fade, though not for billions of years. Yet even after the sun is gone, other stars will remain. The Milky Way alone holds over 100 billion stars. The observable universe holds, at minimum, 100 billion galaxies. And many of those stars have planets. Some of those planets may have oceans, and winds, and skies, and perhaps, in the gentle cradle of gravity and time, life. There may be other eyes, in distant skies, looking up at their own constellations, asking the same questions we do. Wondering about time, space, death, and birth. Wondering what happens when the stars go out. Wondering if the blackness between the stars is as empty as it seems, or if it too is alive. And though black holes are strange and powerful, they do not rule the universe. They are part of its rhythm. Stars are born, they live, they shine, they die. And through that cycle, the universe evolves. In a sense, stars are the storytellers. Every atom in your body, carbon, oxygen, iron, was forged in the heart of a star that exploded long before the Earth even existed. You are stardust given form. A moment of consciousness wrapped in ancient light. That is the quiet, radiant truth beneath all the mathematics and mystery. The universe is not just equations and dark horizons. It is also light. It is wonder. It is the silent gift of stars that shine through distances we can barely imagine, their light crossing millions of years just to reach us. When you look up at the night sky, you're looking into the past, into moments that happened long before you were born. Some of the stars you see may no longer even exist. But their light, travelling faithfully, still arrives, still illuminates your eyes, still whispers across time. Even when we speak of black holes, of the places where light is trapped, where time bends, where escape is impossible, we must remember what came before. Every black hole was once a star, and before that it was gas, drifting through space, gathering in spirals, touched by the hands of gravity and time. The darkness is born from light, and perhaps someday we'll return to it. The universe, then, is not just a place of collapse, it is a place of balance. For every mystery we descend into, there is a light guiding the way back. For every question about death, there is an answer hidden in birth. For every black hole, a billion stars. Even as you've drifted through the depths of the black hole's enigma, through singularities, wormholes, paradoxes, and the long silence of space, the stars have continued to shine, unconcerned, undisturbed, constant, quiet. They do not panic when light falls in. They do not weep when time slows. They shine. And perhaps that is the simplest, most comforting truth in all of this, that amid all the complexity of the cosmos, there are still stars, and they are still shining. They shine before we arrived. They shine now. They will shine long after we are gone. And when we look up, whether from a mountaintop, a quiet bedroom window, or the dreamlike edge of a thought, we see not just fire in the dark, but memory, meaning, and hope. We see the proof that the universe, despite its darkness, is full of light. And maybe that light is enough.